Hello everybody, welcome into another lesson. So today we are going to talk about finding the area of an oblique triangle. And as a review from yesterday, an oblique triangle is simply a non-right triangle. It's any other type of triangle. So to find the area of an oblique triangle, we can actually use trigonometry to do that. As long as you know two sides and the included angle, you can find the area. So this works on So this works on, I should actually say side angle side, not angle side angle. So this method works on side angle side triangles. So if you know two sides and the included angle of those two sides, you can find the area. So there are three forms of the formula depending upon what you're given. You have the area equals half of AB times the sine of angle C, or the area equals half of AC times the sine of B, or the area equals half of BC times the sine of A. It's all going to really depend on what you've been given to work with. So let's do some examples of this. Alright, so they give you that angle C has a measurement of 110 degrees. They give you that side A has a length of 6. Then they give you that side B has a length of 10. So we know sides A and B, then we know angle C. We don't have to know the other side or the other two angles. None of that matters. We have what we need to find the area. So in this case, we'll take the area, set it equal to 1/2, and we're going to use the AB sine of C formula since we know sides A and B in angle C. So side A had a length of 6 times your side B, which had a length of 10, times the sine of angle C, which in this case is 110 degrees. So that's going to equal half of 6 times 10, which is going to be 30 times the sine of 110 degrees. And then let's take a 2 decimal place approximation for this. So let's do that real quick. So to 2 decimal places, you get an area of approximately 28.19 units. So these will largely be decimal approximations again, but the area of this particular triangle would end up being about 28.19 units. So as you see, this is not going to be terrible to work with at all. Alright, let's do some more examples here. So this time we're given that angle B is 130 degrees, and I apologize if this isn't drawn to scale. I just simply don't want to keep redrawing the triangle. Alright, side A has a length of 92, and then side C has a length of 30. So we know sides A and C, and we know the included angle B. So we can use the formula that area equals 1/2 times AC times the sine of B. So let's go ahead and do that. So area would equal half of side A, which is 92, times side C, which is 30, times that sine of angle B, which is 130 degrees. So now we should be able to get a 2 decimal place approximation. So to 2 decimal places, you should get an area of approximately 1,057.14 square units. So the area of this particular triangle should be about 1,057.14 square units. I have about 6 more of these. Alright. Angle A is 38 degrees and 45 minutes. Side B has a length of 67. Side C has a length of 85. Alright, so we know angle A, then we know sides B and C, so we can use this formula. So we'll use the formula for area equals 1/2 of BC sine of A. So area would equal 1/2 times side B, which is 67, times side C, which is 85, times the sine of 38 degrees and 45 minutes. Well, this would turn into 1/2 times 67 times 85 times the sine of, alright, so what's 38 degrees and 45 minutes? That's 3/4 of a degree, so that would be the sine of 38.75 degrees. Now we should be able to get a 2 decimal place approximation for the area of this triangle. So to 2 decimal places, the area is approximately 1,782.32 square units. So you should get an area of approximately 1,782.32 square units for this triangle. I have about 5 more, then we're done with the lesson. This is all we're going to cover today, so this won't be terrible. Let's see what we're given this time. No, I only have 3 more. I thought it was 8 less than 8. It's only 6. Well, even better. Alright, so angle A is only 5 degrees and 15 minutes. Side B has a length of 4.5. And then side C has a length of 22. Alright. So we have 2 sides in the included angle, so we can use this formula. Since we are given sides B and C in the angle A, we'll use the area equals 1/2 of BC times the sine of A. So the area would equal 1/2 times side B, which is 4.5, times side C, which is 22, times the sine of 5 degrees and 15 minutes. Well, 15 minutes is 1/4 of a degree, so this would really be 5.25 degrees. So now we should be able to get a 2 decimal place approximation for this. So take that times the sine of 5.25. You should get an area of approximately 4.53 square units. So the area comes up to approximately 4.53 square units. That's a rather small area, but sometimes you'll have that. And I only have 2 more. Alright. Angle B is 75 degrees and 15 minutes. Side A has a length of 103. Side C has a length of 58. Alright. So we know sides A and C, and then we know angle B. So we can use the area equals half of AC times the sine of B. So the area would equal 1/2 of side A, which is 103, times side C, which is 58, times the sine of 75 degrees and 15 minutes. Well, 15 minutes is 1/4 of a degree, so this would be 75.25 degrees. So now we should be able to get a 2 decimal place approximation for the area. So let's do the multiplication. 103 times 58, divide that by 2, then take that result times the sine of 75.25. You get an area of approximately 2,888.57 square units. So the area is approximately 2,888.57 square units. I got one more, then we're done. Okay, that's side C, this is side A. Alright, let's fill in the information. Angle C is going to be 85 degrees and 45 minutes. Side A has a length of 16. Let's see what B is. B has a length of 20. Alright, so we know sides A and B, and then we know angle C, so we can use the area equals 1/2 of AB times the sine of C. So the area is going to equal 1/2 of that side A, which is 16, times side B, which is 20, times that sine of 85 degrees and 45 minutes. Well, 45 minutes is 3/4 of a degree, so that would actually be 85.75 degrees. So now we should be able to get a 2 decimal place approximation for the area. Take that times the sine of 85.75. So for the area you get approximately 159.56 square units. So the area of this triangle is approximately 159.56 square units. Now, I would like to point something out. You can use this on a right triangle because, well, the sine of C, usually angle C in a right triangle is the right angle. The sine of 90 is just 1, so you're literally left with 1/2 of the base times the height. So actually your classic geometry formula for finding the area of a triangle comes from the area of an oblique triangle formula. So we have that method for solving for right triangles, or if it's an oblique triangle you have to draw the altitude and then use half the base times the height, or what we've learned today with this method allows you to deal with the area of a triangle more directly if it's an oblique triangle. Now, 2 lessons from now we're going to learn one more method for finding the area of a triangle that it's going to be called Heron's formula, and that's if you know all 3 sides of a triangle, but we'll get to that then. But the very next lesson is going to be the law of cosines. So I hope everyone has a great day. Take care.